Hi all, thank you for tuning to my channel. This is the first session of my course in the ozone technology. I hope you'll find this course interesting, challenging and fruitful. There will be some sessions that you will already know well. You can skip them, but those who have no such prior knowledge, it'll be wise to stay on. I try to be as simple as possible. The fundamental knowledge pertaining to this technology is very important. So you'll understand how ozone works and how to apply ozone in the industry. Ozone was first discovered in 1840. It took 15 years before it was applied into healthcare. The next stage of development was in the disinfection of drinking water in the 19th century in Europe. Ozone also was successfully used for several city water treatment systems late in the 19th or 20th century in USA in 1993. Even without any recognition by the United States administration. You will know that even before, like in 1856, if you notice that ozone was used in healthcare for disinfection of operating rooms and sterilizing surgical instruments. In the 19th century, it was used for treating water, for destroying bacteria, killing bacteria and destroying virus, which was established in Europe. And 1893, it was used for disinfectant in drinking water. Now, after the invention of antibiotics, that is penicillin, and further development of antibiotics, that became the vogue. And there was no more development of application of ozone in the medical industry. And I think that is the reason why ozone is almost died. But there is a resurrection of the ozone because of the ozone application and because of the pollution of chemicals and the environmental hazards. In 1909, ozone was used for preservative and storage of cold meats. The effect of ozone on microorganisms were found in much earlier, but actually in 1939, they found that it can stop the growth of yeast and mold during the storage of fruits. So it was used for preservation of fruits. Now, in 1982, the Food and Drug Administration finally declared ozone as GRAS, that is generally recognized as safe for use in bottled water. As you know that ozone was applied in industrial use, particularly community water treatment, large-scale municipal water treatment, uh, very well, despite the fact that the FDA did not recognize it. In 1995, of course, ozone use for bottled water was renewed, and still the FDA had not given full support. In 2000, they used for additive petition for water and air use of ozone, and still the FDA has been sitting on its feet. Even though there has been no more approvals, ozone is already being very widely used in many fields, including medical and pharmaceutical. It is hoped that eventually Congress will relent once it is disconnected financially from the wealthy drug and commercial companies. Germany, Russia, and Cuba are the leading countries in the world that use application of ozone in medicine. Australia recognizes ozone for swimming pool treatment, and briefly, New South Wales had regulations with my help that allow ozone for cooling tower water treatment with strict conditions. Now, there is a change in the regulation which allows, which includes allows ozone to be used as well as other chemicals as long as they are registered and they do the job well. Ozone has not been expanded in the world mainly because of criticisms by competing chemical and drug companies, falsely emphasizing ozone is a very toxic gas or that it causes severe corrosion to metals in cooling towers. I have been successfully maintaining ozone treatment for commercial cooling towers in Sydney for a number of years until 1999 when I left Sydney to go to the Gold Coast in Queensland. Ozone has a formula O3. It is also known as triatomic oxygen or activated oxygen. Oxygen is a very strong oxidizing agent, but ozone is even much stronger oxidizing agent than oxygen. The smell of ozone is characteristic of the smell of freshness often experienced at the seaside. The addition of the new oxygen atom to the oxygen molecule requires a very high energy input. This results in a very unstable ozone gas, which will immediately release the oxygen atom in subsequent reactions. For this reason, ozone cannot be bottled. The chemical companies would have loved it if it could be, as they can start a big industry simply because ozone reconverts to oxygen if it's kept in the compressed in bottles. Therefore, the ozone can be only used in applications in situ or on site. The human nose senses ozone at a concentration of 0.002 ppm has a very sweet smell, but at a concentrations of above say 0.02, zero point 0.102, zero point 0.1 and zero point 0.02 ppm, the smell becomes very irritating. And as it increases, it becomes so much irritating that the person will be forced to leave the area. During thunderstorms and severe lightning, one oxygen molecule dissociates to ozone atoms, which can combine with an oxygen molecule to form ozone. At the same time, ozone or oxygen atom, assisted by moisture, will react with the nitrogen gas in the atmosphere to form nitrous oxide. The oxides of nitrogen dissolves in the water to form nitrous or nitric acids. This process is called the nitrogen cycle. This is a diagram of the ozone cycle and the nitrogen cycle. You will note that the exhaust gases of vehicles that contain nitrogen or nitrogen oxides, they go up into the atmosphere and with the help of UV will form nitrous oxides and release that extra ozone oxygen atom that will combine with another oxygen molecule to form ozone. This is actually the so-called pollution detector. Now, of course, the nitrogen oxides can also just dissolve in water and form nitrates. That is part of the nitrogen cycle. So, the nitrogen cycle and the ozone cycles, they're all very, very closely linked. The ozone is formed indirectly from position of NOx or nitrogen oxides on VOCs and the chemical reaction of UV light. Unlike naturally formed ozone, industrially formed ozone formed from smog or ozone cycle begins that is difficult to break. This causes slowly rising to ozone levels in our environments that are unhealthy. You will note that ozone plays a very important part in the nitrogen cycle. Oxygen is not such a strong oxidant to react with oxygen molecule under normal circumstances. However, in the upper atmosphere, the lightning activates the oxygen to oxygen atoms that will react with the oxygen molecule to form ozone. In the process, ozone also will react with the moisture like the oxygen with nitrogen to form oxides of nitrogen. Oxides of nitrogen dissolve in water to form nitrites and nitrates. This method of ozone that is formed in the atmosphere is used for us to manufacture ozone for our industrial purposes. So we notice ozone is formed in the atmosphere with the lighting energy activating the oxygen. As you know, ozone is sometimes called activated oxygen. It is also noticed that oxygen can be activated by UV, another strong wavelength of light, to form ozone. The above principles are used to manufacture ozone that will be described later in the sessions. UV also can activate ozone further to break up into oxygen and hydroxyl free radicals. That will also be explained in the later sessions. This property is used in the measurement of ozone and also used for very difficult to oxidize systems. The picture on the left is a device for measuring ozone, or it is called the ozone analyzer. The principle used in is the proportional absorption of ozone and the corresponding reduction of UV that is used to determine the concentration of ozone in the air. In the analyzer, you note three channels. The first channel allows the test sample, which is destroyed by the UV, and pass through the ozone detecting chamber. This will be the spam adjustment. The second channel allows the test sample, which is absorbed by a chemical and then sent to the detection chamber. This is the zero channel or zero test. The third channel is a sample test channel where a known flow rate of sample is passed through for detection and measurement. Each process is done separately. The detector is calibrated in the factory using standard ozone, and it gives out the reading of ozone in parts per million. This is a picture of a portable ozone detector and analyzer. It works on the same principle. It has been standardized in the factory, and there is a small pump that sucks in ozone, and it is absorbed by a UV lamp, UV light. And there's a detector which detects the amount of UV absorbed. This is very useful because it's portable, and you can take it with you anywhere in the room, and you can test how much of ozone is in the room, in the air. There are other different types of detectors, and analyzers that can be wired directly so that it can be also put into alarms when the concentration of ozone rises to a critical level where it is not very good for the humans. There will be an alarm sound, and the ozone production can be immediately stopped. The ozone analyzer I introduced is for detection of ozone in the air. For the detection of dissolved ozone in the water, the oxygen potential of ozone is used. There is a reference electrode to which is applied a constant potential. There is a counter electrode that provides a constant or potentiostatic status. The dissolved ozone will disturb this status, and the measuring electrode will detect the change to determine the ozone concentration. The ozone electrode detects the applied voltage change, which can be equated to a specific concentration. There are cheap commercial dissolved ozone meters available for ozone analysis, but not for accurate analysis. I have used the ORP electrode to measure the potential and assess the sterility of the water, which is above 3 at 700 millivolts, which I will explain in later sessions. The picture on the right shows a BMT analyzer for dissolved ozone. This is an expensive analyzer. There are cheap commercial dissolved ozone meters available, but not for accurate analysis. It can be used for standard commercial applications. Before the advent of ozone analyzers, we used to measure quantitatively the amount of ozone through the iodometric titration methods. Ozone is as an oxidizing agent reacts quantitatively with sodium or potassium iodide, and iodine is formed. This iodine can be titrated with sodium thiosulfate using starch solutions that turns blue to a colorless endpoint. This has been a traditional method before the ozone analyzer has been developed. Now, there are conditions that we have to use, such as addition of sulfuric acid, which has to stabilize the ozone that is already produced, because, as you know, ozone is a very quick reacting substance. This is immediately stabilized at the time just before the titration. But if anybody is interested in learning more about this method, could you please look up on the internet, and you will be able to see the exact methods. The addition of sulfuric acid is to mask any chlorine-related products such as chloride and hydrogen peroxide, etc., that also can create issues and mask the actual ozone level. This titration is pretty complex, and you've got to be pretty well trained to be able to do this method, because the endpoint can be different to different people. Indigo titration is another method that has been used with the iodometric titration. The indigo gives some color when ozone is passed, and the amount of color that is produced is proportional to the amount of ozone, and so we will be able to work out how much of color and therefore how much of ozone. What we do is, again, because of high reactivity of ozone, we will try immediately to convert the color to the addition of indigo trisulfonate whenever the ozone cannot be measured directly by its UV absorption. The method is stoichiometric, that is proportional, and it's extremely fast. There is a change of absorption when ozone is added, and this is detected by the spectrophotometer or colorimeter, and is independent generally of other interfering substances like chloride and hydrogen peroxide, etc. But chlorine must be masked because chlorine is like iodine of the same group, and so they can interfere with the determination. This is the end of session 3. Please go to the next session, session 4, for fundamentals of chemistry. It'll be uploaded within 2 weeks. Please click the like icon or the subscribe icon if you like what I have presented to you. Thank you very much and have a good day.